Then after we got the likelihood and prior, we can got the posterior. So we simply just multiply prior with likelihood. So the post equals to a function take theta, where we just multiply prior times likelihood. Okay, because we ignore the normalizing constant. Okay, now we can simply write the post function to have R evaluate the posterior density at each value of theta. We want to simulate a sample from the density posterior, use the Metropolis method, and we'll run a Markov chain, let's say for number of iterations. Choose a starting value for the theta, right? We can choose, say, mu1 0, sigma 1. Those sigma has to be positive, and let's call it theta 0. Given a current state theta, decide on a way to propose a candidate mu. Let's say we call candidate CAND. And then after we got this candidate, we're going to evaluate the posterior on the current state and the posterior on the candidate, and take the ratio. And then we'll record all our results in a big matrix called results, where the dimension is n number of iterations by 4, because we have 4 parameters here. The first row of results will be the starting value, the initial value theta 0, and each successive row of results will be recalled the next theta vector as we run the Markov chain. So let's look at part of the R code. The starting values, we just make mu1 equal to 10, sigma 1 is 10, and everything is 10. So theta 0 is those starting values. Here, what does the MCMC did is the following. Okay, the MCMC contains several methods, right? We learn Metropolis method and Metropolis Hastings method, and there are other methods, but here we just use Metropolis method. Number of iterations is 10,000. Results is a matrix where everything is 0. Dimension is the number of iterations by 4. Theta equals to a starting value theta 0, and results, the first row is just theta 0. And here is the for loop for Metropolis. IT is the iteration from 2 to the total number of iterations. First, we need to propose a candidate, right? The candidate equals to the current theta plus a noise. This noise is generated from normal distribution, right? We generate 4 noise because we have 4 parameters in theta, and standard deviation is 0.5. Now remember, if you generate this noise, it's possible that you make sigma 1 or sigma 2 to be negative, right? But that's okay, because when we calculate ratio, remember the post equals to prior times likelihood. So if your sigma 1 or sigma 2 is 0, then in the prior, that will make everything equal to 0. Okay, so we don't need to worry about that part. Okay, the ratio is posterior of candidate divided posterior of current state. Okay, and then again we use the same if statements. If ratio is bigger than 1, we always accept. If ratio is smaller than 1, then we accept with probability equal to ratio. Okay, then after we do this, we'll save whatever the theta is into our results. Okay, and of course, after you run this, the whole thing, you can use edit to look what's in the results exactly. Okay, now we got a bunch of parameter vectors, and we can use those to answer questions. Okay, so let's see if we can